the last lecture, we have seen the two formulas for binomial expansion. Today we will be solving a few sums from the very first formula that we learned from the binomial expansion. This was the first formula where if we had two terms a and b raised to the power of n, the formula used to go like n c 0, then a to the power n minus 0, b to the power 0, plus nc1, a to the power n minus 1, b to the power 1, and so on. The value of the power of a would decrease gradually and the power of b would increase. The power of the first term would decrease and the power of the second term would increase. So let us try to do the first sum. Here we are asked to find the coefficient of x to the power 7. The coefficient of x to the power 7 is required. So we know that if you look at the formula here, for the coefficient of x to the power 7, x to the power 7 was the second term. So the second term, whatever the second term has in power, that is what you write in the subscript in here. If you have b squared, the square to the second, if you add square to the second term, then you write nc2. If you have the power of r in the second term, then you write ncr like this. This is the formula for any term in general if you are using the NCR formula. This is the formula for any general term. So let's see how we can apply this one. We are asked to find out the coefficient of x to the power 7. So x is in the second term. Let us first write the general term. What is the general term? The general term is NCR. Then we have a to the power n minus r, and then we have b to the power r. So this is our general term. Now if we substitute the values of a and b and the values of r that we need along with the value of n, we know n is 10. Whatever is here, that is the value of n. Let us compare the general formula. We have a plus b to the power of n. So n is 10 in here. So for coefficient of x to the power 7, we will have 10c. Now we need, let's stop r for now. A is 1, so we will have 10 minus something in here. We don't know what we will get in here. These are empty boxes. We will put in values in here. We don't know the values of r yet. And then we have b to the power. B is what? B is x by root 3 to the power of r. Now we need x to the power 7 as the coefficient power. So definitely this should be 7, right? So we need to write 7 in place of r. 7, 7, and 7. So this gives us 10c7. 1 to the power anything is 1 only. And then we get x to the power 7 by root 3 to the power of 7. Now for the coefficient, we know that coefficient of x to the power 7 means any term or any number that is with x to the power 7. So what do we do? The coefficient is 10c7 into 1 by root 3 to the power 7. So 10c7 from our calculators, we know how to find 10c7. So we will substitute that in here. Now for 1 by root 3 to the power 7. Now if you put this down directly in your calculator, you are not going to get a very nice surd. But we are asked to give our answer in the form a root 3, which is somewhat an exact expression, right? So what do we do in here? We have to break this root 3 to the power 7 down manually, as how we have learned. So we know root is a even power. So for any even powers, we will get a direct answer from the calculator. For an even root, if you raise that, any even root, if you raise that to an even power, you're supposed to get an exact answer from the calculator. So for square root of 3, what we will do is, we will write this as square root of 3 to the power 6, and then we will have root 3 left, because 7 is written as 6 plus 1. So we can write this as 120 into 1 by root 3 to the power of 6, and then root 3 with it. So root 3 to the power of 6 is going to give you 27. So we get 120 into 1 by 27 root 3. Now you know how to rationalize this root 3. To rationalize this root 3, you can multiply the numerator and the denominator with root 3. So you are going to get 120 into 1 into root 3, which is 120 root 3. And in the denominator, you will have 27 into root 3 squared. So 27 into root 3 squared. And if you simplify this down, you get 120 by 81, because the square and the roots get cancelled out. So you are going to get 27 into 3, which is 81. Now multiply 27 and 3, you get 81. Now we want to divide 120 by 81. So 120 divided by 81 is going to give us 40 by 27. So our final answer is 40 by 27 root 3. See, in the question, it is given to us that a is a rational number. A being a rational number means A can be a number which is a fraction. A can be a number which is a whole number. Rational means A can be both an integer and a fraction. So our value of A is 40 by 27. If you get confused in how to break this down, if you get confused in this step, like how we achieved this step or how we understand this step from this, then you can think it like this. See, you have to the power of 7. So you're going to get root 3 multiplied 7 times. So root 3 into root 3 into root 3. It will continue. So we have 4, then 5, 6, and 7 times. Now see, for every 2 pairs, you will get a root 3 whole square, which will give you 3. So for these two, you're going to get root 3 whole square. So the square and the root will get cancelled out and you will get 3 only. In the same way, from these two, you will get 3. Then from these two, you are going to get 3. So 3 into 3 into 3, 3 cube. And then you have root 3, which is 27 root 3, which you have written here, which you got in here. It's the same. So I hope it is clear. Let us review it one more time. We were asked to find the coefficient of x to the power 7. So what we did was we first figured out what is the term in x to the power 7. So we wrote the general formula first. We know this is the general formula for any term. So we wrote that down first. Then we need the coefficient of x to the power 7. So for coefficient of x to the power 7, we need the term in x to the power 7. X to the power 7, how will we get that? We saw that x is the second term, right? So if x is the second term, then it is somewhere here. So we did not write the values of r. We kept it as r first. And then we substituted all the other values. We put the value of n, we put the value of a, we put the value of b. After that, we saw that for x to the power 7, the value of r must be 7. So we put 7 in here. Now, if the value of r is 7, then we substituted r as 7 in here, r as 7 in here. Now, we simplified it. And then for the coefficient, we know coefficient is what? Coefficient is a term. Coefficient of a term is the number with it. Coefficient of x to the power 7 is everything in that term except x to the power 7. Coefficient of x to the power 6 is everything in that term but not x to the power 6. So apart from x to the power 7, whatever we had in there was the coefficient. So we wrote that down and we saw how to simplify it. We simplified it and we got our answer. Now let's take a look at another example. In here, we have to expand this term, simplifying each term as far as possible. Now, how do we simplify this one? First, we need to first expand it. So when we are expanding, we know the formula. So we have the formula of a plus bx to the power of 4. So our formula is, first we have maximum power of a, then we have 4c1 a to the power 4 minus 1 and bx to the power of 1. Then we have 4c2 a to the power 4 minus 2 and we have bx to the power of 2. Then we have 4c3 a to the power 4 minus 3 and bx to the power of 3. And lastly, we have bx to the power of 4. So if we simplify, we get a to the power 4 plus, we can find out the value of 4c1 from your calculator. You put 4 and then shift the division sign, which gives you the c in your input, and then you press 1, which gives you 4. So 4c1 is 4 and then a to the power 4 minus 1 is 3. So a to the power 3 and you have b to the power 1, which you do not write, and then you have x to the power 1 as well. Then in the next term, you have 4c2. So in the same manner, if you press 4c2 in your calculators, you're going to get 6 in here. Then we have a to the power 4 minus 2, which is 2. Then we have b square. The value of b square remains as it is. And we have x square as well. Then we have 4c3. If you press 4c3 in your calculator, you're going to get 4. So 4 a to the power 4 minus 3 is 1, which we do not write. And we have b cube, x cube, And lastly, we have b to the power 4, x to the power of 4. So we have expanded this fully and we have simplified each of the terms. Then in the next part of the question, it says that in this expansion where the value of a and b are not equals to 0, the coefficient of x is equal to the coefficient of x is equal, this is a key term for us, the coefficient of x squared. So we see that whatever with x we have, it is the coefficient of x, and this is equals to the coefficient of x squared. So this is the term in x squared and coefficient is whatever we have with x squared. So these two are equal, right? So this brings us to our first equation. We have 4a cube b is equals to 6a square b square. Now we have to form an equation from here. So how do we form this? We take this 6a square b square to the other side. So we get 4a cube b minus 6a square b square is equals to 0. We dare not cancel the a and b's out because that we know in that way will reduce the number of solutions. We do not want that. So now we can take from 4 and 6 2 common. We can take a square common. We can take b common. So what are we left with? We are left with 2a minus 3b, and this is equals to 0. Now in the question, see, it is already given to us that a is not equals to 0 and b is also not equals to 0. So if a and b is not equals to 0, both of these are not equals to 0, and when you multiply a square b and 2a minus 3b, the product is 0, which means what? If this is not 0, this is also not 0, 2 is definitely not 0, then it means that 2a minus 3b is most likely to be 0. So 2a minus 3b is equals to 0. This is our first equation. Now for the second equation, see, in the question it is given also when x is equals to 2, the value of a plus bx to the power 4 is 2401. So when x is equals to 2, so you put x is equals to 2 in here. So a plus the value of x is 2 in here. In here the value of x is 2. Here you are going to put the value of x as 2. So you are going to get 2b to the power 4, and this is equals to 2401. Now we know that if we have a fourth power, then that it goes to the other side and becomes fourth root, right? So fourth root of 2401, if you put this in your calculator, you have a plus 2b is equals to fourth root of 2401, and from your calculator you get 7. But is this correct? Are we not missing something? We know that for all even powers of 2, 4, 6, 8, 10, 18, 16, 32, whatever power we take, for all even powers, when you do a root, you get a plus minus sign. So you're going to get plus minus fourth root of 2401. So you get a plus 2b is equals to plus minus 7. So from here, you actually get two equations. So from here, you get two possible equations. One is, let me take some space in here. We have either a plus 2b is equals to minus 7, or a plus 2b is equals to 7. So we have two possible equations, both of which are parts of our equation 2. So this is our equation 2a. Let's say we name this equation 2a, and let's name this equation 2b. Now we know we have to take one from equation 1 and we have to take one from equation 2, and then we need to solve. That's how we solve simultaneous equations, right? We take one equation from here, we take the equation that we get from here, we solve them simultaneously. So in the first case, what we will do is we will take in this one and this one. So we have 2a minus 3b is equals to 0, and a plus 2b is equals to minus 7. Now, if we want, we can solve this very easily. We have learned the solving techniques. You can use simultaneous equations, elimination method. You can use substitution method. So when you solve it from here, you're going to get the value of a as minus 3 and the value of b as minus 2. Now we pick the other equations. So our alternate solution is what? Definitely equation 1. You have only one equation in here, so you have to pick this equation again. So we have 2a minus 3b is equals to 0. And from here, you have already picked this one. So solving these two again doesn't make any sense. So we are going to pick this one now. And we solve a plus 2b is equals to positive 7. So when you solve these two now, using again the same method, elimination or substitution, whatever you prefer, you are going to get the value of a as 3 and the value of b as 2. So these are our final answers. Our possible values of a are plus minus 3 and our possible values of b are plus minus 2. So a quick recap of what we did in here. We had to expand this. First, the expansion that we were asked to do is we were asked to expand a plus bx to the power 4. So we expanded that using the formula that we have learned. We know 4 is a positive integer. So definitely the combinatorics formula can be used in here. The binomial theorem formula, we have used that one. Then we were asked to find out the possible pairs of values of a and b. We were asked to find the possible values of a and b. And for finding out those values, the first condition given to us was that in the expansion, coefficient of x is equal to coefficient of x square. So coefficient of x is given to you. The coefficient of x square is also given to you. You have yourself found that out in the first part. So taking those two, we found out an equation. Then for the next equation, it is said that when the value of x is 2, the value of a plus bx to the power 4 is 2401. So in place of x, you put the value of 2, and then from there you formed another equation. But here we have a trick. How so? Because in here we have a plus minus sign for the fourth root. We know fourth root, sixth root, 10th root, 8th root, 18th root, all of these roots are even roots. For even roots, we always get a plus minus sign. So we put plus minus in here, and from there we get two sets of equations. Now what do? We did a very simple thing, which was we know that for simultaneous equation, from this condition we will pick an equation, from the other condition we will pick an equation, and then we will solve it. So from the first equation we only had one condition, from the first condition we only had one equation, so we picked that equation, and from the second one we picked either of these, anyone you like. We picked it and we solved it. Now for the second part, from the first condition we only have one equation, so you have no other option, you have to pick this equation. And for the second condition you have one more condition left, you have one more equation left to pick, so you picked that other one, and from there you solved to find out the values of a and b. Now let's move to the third example. The third example is a much more easier example. Here you are said that the coefficient of x square is 1 plus 2 by 5x to the power n. In the expansion is 1.5. From there you are asked to find the value of n. So, and in the question it is also given that n is positive. So for this one you can choose two approaches. Either you can, if n is not mentioned to be positive, then you have to follow some other formula, but here n is given to us as positive, so we can use the binomial theorem formula or the combinatorics formula which we have learned, the first formula. So for coefficient of x square, now you can take two approaches. The first approach is you can expand the first two terms using the formula, or simply what you can do is you have the coefficient of x square as 1.6, so you write the general term. What is the general term? We know that the general term is NCR, and then we have a to the power n minus r, and we have b to the power r, right? So let us try to figure out how to do this one. For the coefficient of x square, for coefficient of x square, we need the term related to x square, right? So let us try to rewrite the general term. We have n as n, because that is the value that we need to find out. We have c, and let us write r as r for now. Then we have a, the value of a is 1, so we write a to the power n minus r, both of which we do not know for now. And then for b we have 2 by 5 x to the power r. Now we know that we need x square, right? Coefficient of x square, we need x square. So instead of r, we need 2 to make x square in here. So our general term can be rewritten as NC2. Now 1 to the power anything gives you 1. So writing this is not necessary, right? And we have 2 by 5 x to the power 2. Now we need the coefficient because that is mentioned in the question as 1.5. So, sorry, 1.6. So we have NC2 2 by 5 whole square, because x square is not required for us to write. Coefficient means whatever is with x square. So this is equals to 1.6. Now NC2, we have seen that NC2 can be written as NCR can be written as n factorial divided by r factorial into n minus r factorial. So we are going to apply the same thing in here. We are going to write this as n factorial divided by r factorial into n minus r factorial. And then for 2 square we have 4, for 5 square we have 25, is equals to 1.6. So now 1.6 can be divided by 4 by 25. Since 4 by 25 is multiplied in here, it goes to the other side and gets divided. So we can write this as 1.6 divided by 4 by 25, which is going to give us 10 from our calculators. And we have n factorial divided by 2 factorial into n minus 2 factorial is equals to 10. Now we need to find out the value from this. We need to find out the value of n. So how do we proceed this? Now we know that n factorial means that we will multiply 1, 2, 3, 4 and all the numbers up to n. So if we try to write it backwards, what do we get? N factorial is what? If we try to write it backwards, n factorial would be n. Then we will have n minus 1, one number less, right? Because here you have 2, then 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. Like this, we are going to get all the numbers. So if you write it backwards, you are going to get n, n minus 1, n minus 2, like this, 4, 3, 2, 1. And then we have n minus 2 factorial. And then in the denominator, 2 factorial is 2. And then we have n minus 2 factorial in here, and this is equals to 10. Now the reason I did not go backwards all the way up to 1, down to 1, the reason for that is I have n minus 2 factorial in here. I know if I write n minus 2 factorial also, let us try to understand from this example, this small example. If I have 5 factorial, then 5 factorial means what? 1 into 2 into 3 into 4 into 5. And if I have 3 factorial, then 3 factorial stands for 1 into 2 into 3. So I am writing these three numbers repeatedly. So instead of writing 5 factorial like this, if I want, I can write 5 factorial as 5 into 4 into 3 factorial, because 3 factorial would mean 3 into 2 into 1. So if I keep on writing this till 1, then for n minus 2 factorial, I also have to write n minus 2, n minus 3, and all the way up to 1, which is definitely not required. I can directly cancel these out. So this is why I wrote n minus 1, because I can cancel n minus 2 factorial and n minus 2 factorial out in here. So I'll get is equals to 10 in here. Now if I cross multiply and try to solve it, I have n into n, n square, minus n into 1 is n, is equals to 2 into 10, which is 20. So I get n square minus n minus 20 is equals to 0. Now I can solve it using middle term break or whatever formula if I want to. I have the polynomial formula, the quadratic formula that I want to use. If I want to use it, then I can use it, and I'll get n is equals to minus b plus minus root over b square minus 4ac divided by 2a. And if I solve it, I'm going to get the values of 5 and minus 4. But if you see the question, my value of n was positive. That's how we could use the general term formula, right? So minus 4 will not be an accepted answer. Our answer will only be n is equals to 5. This is not acceptable. So let us try to do a quick review of what we did in here. we were asked to find out the value of n, where the coefficient of x square was given to us as 1 plus 2 by 5x to the power of n is 1.6. So in order to find out the coefficient of x square, we need the term in x square. So that brings us to the general term. Our general term is NCR a to the power n minus r b to the power r. So instead of writing the value of r directly, what we did was we let r sit for a while. We substituted the values of n, a, and b. And then we saw that in order to get the term in x square, we need the value of r to be 2. So we put 2 in here. We know 1 to the power anything is 1. So it's a waste to write it down. We did not write it down in here. Then we know the value of NCR. We use the formula for NCR. We know NCR is n factorial divided by r factorial into n minus r factorial. We wrote it down. We evaluated 2 by 5 as 4 by 25, and then we did not write the value of x square or the x square with it because we were concerned with the coefficient of x square. Coefficient of x square means everything with x square. So everything with x square is n by nc2 2 by 5 whole square. So that is equals to 1.6 given in the question. We wrote it down. And from there, we were asked to evaluate for n. Now, in order to find out the value of n, we need to break down the factorial. We know factorial means multiplying or the product of all the terms, all the numbers from n all the way down to 1. So for n, we wrote n, then the next term, the next smaller term is n minus 1. The next number is n minus 1, which is n minus 2. So we added factorial in there. And then 2 factorial is 2 from our calculators. And n minus 2 factorial just sits right there. Now we can cancel out n minus 2 factorial and n minus 2 factorial. The reason for that is because these two are going to give me the exact same value. So I cancelled these two out. And then I'm left with n minus 1, 2, and this 10. So now I can multiply this and solve it like how I have been solving all of the other equations. So we solved this down and we got two values which are 5 and minus 4. Now the value of 5 definitely is our answer and not minus 4 because n was a positive integer given in the question. So we crossed out the possibility of n being a negative number in here. In the next one, we will try to solve two more sums related to this formula. So let's hope to see each other in the next one. That's it for this lecture.